Now, in this lecture, we find out the radius of a circle. In the drawing, we have triangle ABC. This is triangle ABC, that is a right angle. You know that line segment AS equals to 1 unit in its length. Line segment ST equals to 3 units. And this is line segment TC that is equals to 2 times square root of 3 units in its length. This is angle ABC that is a right angle. Inside this right angle triangle ABC we have this circle, and our mission is to find out the radius of this circle. Okay. So first of all, we will define the center of this circle as O, this point as O. And we will define the radius of the circle as x. So the radius, that is the radius that we are looking for, the radius of this circle is equals to x according to our definition. We join points O and Q together by a straight line. Point O is the center of the circle, point Q is the point of the circle itself. Therefore, OQ is the radius of this circle that is equals to x according to our definition. We can implement here rule 1. According to rule 1, tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle and we have tangent AB. This is tangent AB that is tangent to this circle at point M. Point M is the point of tendency, and we have the radius OM that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. We can implement rule 1 in our drawing. Why? Because in our drawing we have the radius OQ of this circle that is drawn to point Q, that is the point of tendency of tangent BC in this circle. And whenever your radius is drawn to the point of tendency, then tangent BC will be perpendicular to the radius OQ. If BC is perpendicular to OQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we will join points O and P together by a straight line. Point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of this circle that is equal to x according to our definition. Again, we have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equal to 90 degrees according to rule 1. In the next step, we will focus on this quadrilateral POBQ. Inside quadrilateral POBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral POBQ to 360 degrees, the missing angle must be equal to 90 degrees in its size. So we found out that inside this quadrilateral POBQ, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral POBQ with 4 right angles is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, rectangle POBQ, side PO must be equal to the opposite side BQ. So PO equals to BQ. But PO equals to X, therefore BQ must be also equal to X units in its length. Because PO equals to BQ. Likewise, in rectangle POBQ, side OQ must be equal to the opposite side PB. But OQ equals to X, therefore PB must be also equal to X units in its length. Why? Because OQ equals to PB. So all the 4 sides of this quadrilateral POBQ are equal to each other, and this quadrilateral has 4 right angles. Therefore, quadrilateral POBQ is a square. Okay. So in the next step, we'll define side AP, line segment AB. This line segment AP is A. And we'll define this line segment QC is B. Here we can implement rule 10. I'll repeat on rule 10. According to rule 10 is true in any circle. So in any circle, if AB is a chord, if AB is chord inside this circle, and PT, this is tangent PT, that is tangent to this circle at point C. So we have chord AB and tangent PT. So in this problem, the following equation will be true. That PT squared, that is to say, the length of tangent PT squared will be equal to PA times PB. Again, PT squared must be equal to PA times PB. Okay? We can actually implement rule 10 in our drawing. Why? Because if we focus at point A, from point A, we have tangent AP, that is tangent to this circle at point P. Point P is the tangent, is the point of tendency of tangent AP with this circle. And we have here chord ST, and chord TS is extended until it touches point A. Therefore, according to rule 10, we'll get that AP squared must be equal to AS times AT. Again, AP squared must be equal to AS times AT. So I'll write it down. If we focus at point A, this point A, according to rule 10, we get that the following equation is true, that AP squared must be equal to AS times AT. Repeat again, if we focus at this point A, according to rule 10, AP squared equals to AS times AT. So this equation is the implementation of rule 10 in our drawing. AP equals to A according to our definition, therefore AP squared is A squared. And it must be equal to AS. AS is 1 times AT. AT in total equals to AS plus ST. That is to say AT equals to AS, that is 1, plus ST, that is 3. So in total, AT equals to 1 plus 3. Here AT equals to 1 plus 3. In conclusion, we found out that A squared equals to 1 times 1 plus 3. So A squared equals to 1 times 1 plus 3. 1 plus 3 is 4, and 1 times 4 is 4. In conclusion, we found out actually that A squared equals to 4. Here we take a root out of this equation, and finally we get that A equals to the square root of 4, that is 2. We actually found out that A equals to 2 units in its length, so I'll write it down here. We can actually implement rule 10 at point C here. So if you focus at this point C, here if you focus at point C, so according to rule 10, from point C, we have tangent CQ, that is tangent to this circle here, this point Q. And we have also chord ST of this circle that touches point C. Therefore, we can implement here rule 10. According to rule 10, we'll get that CQ squared equals to CT times CS. So again, if we focus at point C, according to rule 10, we get that CQ squared equals to CT times CS. CQ is B, therefore CQ squared is B squared. So B squared equals to CT is 2 times square root of 3 according to what is given us the question, times CS. CS in total equals to 3 plus 2 times square root of 3. So it is 3 plus 2 times square root of 3. In conclusion, we found out that b squared equals to 2 times square root of 3 times 3 plus 2 times square root of 3. Here we'll open the brackets on this side of this equation and we get that b squared equals to 2 times square root of 3 times 3 is actually 6 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3. It's actually 2 times 2, that is 4, and square root of 3 times square root of 3 is 3, and 4 times 3 is 12. In conclusion, we found out that b squared equals to 12 plus 6 times square root of 3. So b squared equals to, we have here 12. We substitute 12 by 9 times 3 plus 6, and then we substitute 6 by 2 times 3. So this expression in total will be equal to 2 times 3 times square root of 3. In conclusion, we found out that actually that b squared equals to 9 plus 3 plus 2 times 3 times square root of 3. And this equation, it is actually very similar to the algebraic identity that a plus b squared equals to a squared plus b squared plus 2 times ab. In our expression, a equals to 3 and b equals to square root of 3. And therefore, a plus b squared will be equal to 3 plus square root of 3 squared. Why? Because a is 3 and b is square root of 3. So we substitute a in this equation, in this algebraic identity, by 3, and we substitute b by square root of 3. And you can see that a plus b squared equals to a squared, so 3 squared is 9, plus b squared, b is square root of 3, therefore b squared is square root of 3 squared, that is 3, plus 2 times a times b. 2 times a is 3, times b is square root of 3. So, according to this algebraic identity, 9 plus 3 plus 2 times square root of 3 times, again 9 times 9 plus 3 plus 2 times 3 times square root of 3 is equals to the expression of 3 plus square root of 3 squared. So we actually substituted this expression 9 plus 3 plus 2 times 3 times square root of 3 by 3 plus square root of 3 squared. Why? Because of the fact that according to this algebraic identity, a plus b squared is equals to a squared plus b squared plus 2 times ab. And this is equals to b squared. So here we take a root out of this equation, and finally we get that B equals to 3 plus square root of 3. So B equals to 3 plus square root of 3. Square root of 3 is 1.732, so in total 3 plus square root of 3 will be equal to 4.732 units. So in conclusion, found out that B equals to 4.732 units. So can I write down here that B, the length of line segment QC, that is B, is equals to 4.732 units. In the next step, we just implement the Pythagoras theorem on this big right triangle, triangle ABC. Repeat again, we will implement the Pythagoras theorem on this big right triangle, triangle ABC. Here, by PT, is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle, triangle ABC, is AC, therefore the square of the hypotenuse is AC squared. And AC squared must be equal to AB squared plus BC squared. Repeat again. In the right triangle, triangle ABC, according to the Pythagoras theorem, AC squared must be equal to AB squared plus BC squared. So here, what is the length of the hypotenuse AC? AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So in total AC equals to 4 plus 2 times square root of 3. And therefore AC squared will be equal to 4 plus 2 times square root of 3 squared. And it is equals to AB squared. AB equals to 2 plus x, or x plus 2, therefore AB squared equals to x plus 2 squared plus BC squared. BC in total equals to x plus x plus 4.732. And therefore BC squared in total will be equal to x plus 4.732 squared. In conclusion, found out actually that according to the Pythagoras theorem, 4 plus 2 times square root of 3 squared, that is AC squared, equals to x plus 2 squared plus x plus 4.732 squared. Here we'll open the brackets on both sides of the equation, and we get that here we have 4 plus 2 times square root of 3 squared. So actually 4 plus 2 times square root of 3 squared, in total it will be equal to 55 4.7128. Again, 4 plus 2 times square root of 3 square in total equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is plus 4x, plus x plus 4.732 square, it is equals to x square plus 4.732 square is equals to 22.3918 plus 2 times x times 4.732, that is actually equals to 9.464x. So we have in this side of the equation 55.7128, and it must be equal to, here we have in this side, on the other side of the equation we have x squared plus x squared, that is 2x squared, and we have here 4 plus 22.3918 is equals to 26.3918, and we have also 4x plus 4x plus 9.464x is equals to 13.464x. So here we will subtract 55.718 from this equation, and we get that. So in this side of the equation we left with nothing, 0, that is equals to 2x squared, and 26.398 minus 55.7128 is equals to 29.321 plus 13.464x. So we have here a quadratic equation. We divide this quadratic equation by 2, and we will get that x squared minus 29.321 over 2 is equals to minus 14.66, and 13.464 x over 2 and here we have plus 13.464x equals to 0. So we have here quadratic equation. The quadratic equation is x squared plus 13.464x minus 14.66 equals to 0. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now specific quadratic equation, x squared plus 13.464 minus 14.66 equals to 0. The coefficient a equals to 1. The coefficient b equals to 13.464, and the coefficient c equals to minus 14.66. Now we put the data inside this general formula for x in order to find out the value of the values of x in our specific quadratic equation. And we get actually that x equals to minus b. B is 13.464, therefore minus b is minus 14.464 plus minus square root of b squared. Actually, square root of b squared is 13.464 squared actually here I didn't divide it 13.464 by 2, so if you fix it, 13.464 over 2 equals to 6.732 again. So the quadratic equation is as follows: x squared plus 6.732x minus 14.66 equals to 0. Repeat again, our specific quadratic equation is as follows: x squared plus 6.732x minus 14.66 equals to 0. Here the coefficient a equals to 1, the coefficient b equals to 6.732, and the coefficient c equals to minus 14.66. Now we put the data inside the general formula for x, and we'll find out the value of the values of x. And we get that x equals to minus b. B equals to 6.732, therefore minus b equals to minus 6.732 plus minus the square root of b squared. The square root of b squared is actually 6.732 square. That is actually 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4, and minus 4 times minus 14.66 is equals to plus 58.64, all divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. In conclusion, found out actually that x equals to minus 6.732 plus minus 58.64. Inside the root we have 58.64 plus 45.3198 again. Inside the root we have 45.3198 plus 58.64 is equals to 103.9598. So inside the root we left only with 103.9598 divided by 2. In conclusion, we found out that x equals to minus 6.732 plus minus, and the square root of 103.9598 is equals to 10.196 divided by 2. So here we have two solutions that are possible for x. The first solution is that x equals to minus 6.732 minus 10.162. We get any negative number, but x is a radius, and the radius is a length, and the length must be a positive number. So the negative solution is incorrect solution. We cancel the negative solution, and we left only with the positive solution for x, that is that x equals to minus 6.732 plus 10.196 divided by 2, and 10.196 minus 6.732 is equals to, again, 10.196 minus 6.732 is equals to 3.464 divided by 2. So x equals to 3.464 divided by 2, and 3.464 over 2 is 1.732 units. In conclusion, we found out that x, that is the radius of this circle, the length of the radius of this circle x is equals to 1.732 units. And that is the answer to the question. I repeat again. The radius of this circle x equals to 1.732 units. Okay, so the next step, I'll summarize the lecture. In this lecture, I found out the radius of this circle. This circle is located inside the right triangle ABC. In the right triangle ABC, this is angle ABC, this is the right angle. We know also that the length of this line segment AS is 1, the length of this line segment ST is 3, and the length of this line segment TC is equals to 2 times root of 3 units. Again, our mission is to find out the radius of this circle. So first of all, we define the center of this circle, this point is point O, and we define the radius of this circle, the radius that we are looking for is x. So the radius of this circle equals to x according to our definition. And then we join points O and Q together by straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and then at point Q, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle. This is equals to x according to our definition. And here we can implement rule 1 because of the fact that the radius OQ is drawn to point Q, that is the point of tendency of tangent BC in this circle. So whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by straight line. OP is the radius of this circle that is equal to x. Here we have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. So actually found out that inside quadrangle POBQ, inside this quadrangle, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees in size. Again, in order to complete the sum of the angles inside this quadrangle POBQ to 360 degrees, the missing angle here must be equal to 90 degrees. So actually found out that inside quadrangle POBQ we have 4 right angles. And any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrangle POBQ as a rectangle. And you also know that the opposite sides of a rectangle are equal to each other. So in rectangle POBQ, side PO must be equal to the opposite side BQ. But PO equals to x, therefore BQ must be also equal to x unit in itself. Why? Because it is equals to PO. Likewise, in rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to x, therefore PB must be also equal to x units in its length. So actually found out that quadrilateral POBQ is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other. Okay? In the next step, we defined the length of this line segment AP as A, and we define the length of this line segment QC as B. So here we implemented rule 10 in our drawing. And then again on rule 10. Rule 10 is true in any circle. So according to rule 10, in any circle, if AB is any chord AB could be any chord inside this circle, and PT is tangent to this circle. Here it's point T. Again, PT is tangent to this circle is point T. Point T is the point of tendency. So in our drawing, the following equation will be true. PT squared, the length of the tangent squared, must be equal to PA times PB. Again, PT squared equals to PA times PB. We can actually implement rule 10 in our drawing. Why? Because in our drawing, if you focus at this point A, from point A, we have tangent AP that is tangent to this circle at point P. Point P is the tangent of, it's the point of tendency of tangent AP with this circle. In addition, we have here chord TS or chord ST. Chord ST is extended until it touches point A here. So all the conditions of rule 10 are satisfied, therefore we can implement here rule 10. According to rule 10, we get that AP squared equals to AS times AT. Again, AP squared equals to AS times AT. And then again, if you focus at point A, according to rule 10, AP squared equals to AS times AT. So AP squared, AP is A, therefore AP squared is A squared. AP squared is A squared, and it is equals to AS. AS is 1 times AT. AT equals to 1 plus 3. Again, AS is 1 and AT is 1 plus 3. So we found out that A squared equals to 1 times 1 plus 3. So A squared equals to 1. 1 plus 3 is 4. So A squared equals to 1 times 4. That is 4. In conclusion, we found out that A squared equals to 4. Here we took out of this equation. And finally found out that A equals to the square root of 4. That is 2. So we found out that the length of this line segment AP, that is A, it is equals to 2 units in its length. In the next step, we focus on this point, is the common extra point, point C. From the common extra point C is the common extra point in relation to this circle. Why? Because it is not located inside the circle nor on the circle. Therefore, it is a common extra point. From the common extra point, point C, we have tangent CQ that is tangent to the circle at point Q, this point, and we have here chord ST that is extended until it touches point C. So all the conditions of rule 10 are satisfied, and therefore we can implement rule 10 if we focus on the common point C. According to rule 10, we will get that CQ square must be equal to CT times CS. Again, CQ square must be equal to CT times CS. Repeat again, if we focus on the common point C, according to rule 10, CQ square equals to CT times CS. CQ is B, therefore CQ square is B square. CQ square is B square. And it must be equal to CT. CT is 2 times square root of 3. According to what is given as the question, so we substitute CT by 2 times square root of 3. And CS in total equals to 2 times square root of 3 plus 3. So again, CS in CS, you can see here, CS in total equals to 2 times square root of 3 plus 3. So we substitute CS in this equation by 3 times square root of 3. In conclusion, found out actually that B square equals to 2 times square root of 3 times 3 plus 2 times square root of 3. Here we open the brackets on this side of this of the equation and found out actually that B square equals to 2 times 3 is 6, so in total this expression equals to 6 times square root of 3. We have 2 times square root of 3 times 2 times square root of 3 is 12 in total. Why? Because 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 4 times 3 is 12. So in total, 2 times 3 times 2 times square root of 3, 2 times square root of 3 times 2 times square root of 3 in total equals to 12. In conclusion, found out actually that B square equals to 6 times square root of 3 plus 12. Here we substitute 12 by 9 plus 3. Therefore, we got that B square equals to 12, that is 9 plus 3 plus, and 6 is 2 times 3. So in total this expression will be equal to 2 times 3 times square root of 3. In conclusion, found out actually that B square equals to 9 plus 3 plus 2 times square root plus 2 times 3 times square root of 3. We use the trigonometric and algebraic identity that A plus B square equals to A square plus B square plus 2 times AB. If we substitute A by 3 and B by square root of 3, we get that A plus B square will be equal to 3 plus square root of 3 square, and it must be equal, according to this algebraic identity, to A square. A square is 3 squared, that is 9. Here we have 9 plus B square. B is square root of 3, therefore B square is square root of 3 squared, that is 3, so we have here 3 plus 2 times AB. So it is plus 2 times A is 3 and B is square root of 3. So 2 times 3 times square root of 3. In conclusion, found out actually that 3 times square root of 3 square equals to 9 plus 3 plus 2 times 3 times square root of 3. That is to say, we can substitute this expression by 3 plus square root of 3 square. According to this algebraic identity, those two expressions are equal to each other. So in conclusion, found out actually that B square equals to 3 plus square root of 3 square. Here we took a root out of this equation, and finally we found out actually that B equals to 3 plus square root of 3. 3 plus square root of 3 is 3 plus square root of 3 is 1.732. 3 plus 1.732 equals to 4.732. In conclusion, found out actually that B equals to 4.732. So you can write down here that the length of this isosceles sheet is equal to B, according to our definition, is equals to 4.732, and we only found out that A equals to 2. In the next step, we actually implemented the Pythagoras theorem on this right big triangle, triangle ABC. Again, we implemented the Pythagoras theorem on this right big triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendicular, of the perpendiculars. So, the hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC square must be equal to AB square plus BC square. So, what is the left of the hypotenuse AC? From the drawing it is very easy to see that AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So in total AC equals to 4 plus 2 times square root of 3. Again, AC equals to 4 plus 2 times square root of 3, and therefore AC square equals to 4 plus 2 times square root of 3 square, and it is equals to AB square. AB is x plus 2, therefore AB square is x plus 2 square. So AB square by x plus 2 square plus BC square. BC in total equals to x plus 4.732, therefore BC square will be equal to x plus 4.732 square. Repeat again, BC square equals to x plus 4.732 square. We open the brackets on both sides of this equation. This expression 4.2 times square root of 3 square equals to, in total, to 55.7128, and it must be equal to x plus 2 square. X plus 2 square equals to x square, plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square. X plus 4.732 square equals to x square, plus 4.732 square, that is 22.3918, plus 2 times x times 4.732, that is actually 9.464x. So here we have x squared plus x squared is 2x squared, and we have here 4 plus 22.3918 is 26.3918, and we have also 4x plus 9.464x equals to 13.464x, and it is equals to 55.7128. So here we subtracted 55.718 from this equation and found out actually that 2x squared equals to, here we have 26.398 minus 55.718 is equals to minus 29.321 plus 14.464x. So in conclusion, we found out actually the 2x squared minus 29.321 plus 13.464x equals to 0. So this is a quadratic equation, and here we divided this quadratic equation by 2, and after we divided this quadratic equation by 2, 2x squared over 2 is x squared, minus 29.321 over 2 is minus 14.66, and 13.464x over 2 is 6.732x. So if we found out actually that x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, it is actually x squared plus 6.732x minus 14.66 equals to 0. The coefficient a equals to 1, the coefficient b equals to 6.732, and the coefficient c equals to minus 14.66. So now all we have to do, what is left to do, is to put this data inside the general formula for x, and we find out the value for x. X is the radius of the circle, the radius that we are looking for. So according to the general formula for x equals to minus b. B is 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. B is 6.732, therefore b squared is 6.732 squared, that is 45.3198. Minus 4 times a times c, so it is minus 4 times a is minus 4 times 1 is minus 4 times c, that is minus 14.66, and minus 4 times minus 14.66 is plus 58.64 divided by 2, and 45.3198 plus 58.64 is equals to 103.9598. So inside the root we left only with 103.9598 divided by 2. And the square root of 103.9598 is equals to 10.196 divided by 2. So here we have two solutions that are possible for x. X will be either equals to minus 6.732 minus 10.196, but the result that we get here is a negative number. X is a radius, the radius is the length. The length must be a positive number, so we cancel the negative solution, and we have to leave the positive solution for x. The positive solution for x is that x equals to minus 6.732 plus 10.196 divided by 2. And minus 6.732 plus 9.1, again, x equals to minus 6.732 plus 10.196, that is 3.464 divided by 2. So if we found out actually that x equals to 3.464 divided by 2, and 3.464 divided by 2 is 1.732. If we found out actually that the radius x of this circle is equals to 1.732 units. And that is the answer to the question. Okay, thank you very much.